Let's understand about the functions now, why we use function, when to use, and how to use it. Okay. So let's have one example here. Just a minute. Let's assume that you're writing a program. Let's create a new program now. I'll not use this. Let's create a new program. I'll say new class uh, function demo. Function demo check. I'm giving just a name of this class, something like this. Okay, we have a new function here. You have a new class here, and let's make a simple program. Integer x is equals to 2 comma y is equals to 5. You can declare it by this way also. Okay, and I will have another integer. Let's say integer z. Okay, and I want to do at once I want to do the addition, so I'll say z is equals to x plus y. Do it with me, whatever I'm doing, so that you will understand what is happening. Okay, and then I want to print this, so I will say I'll say sum is equals to plus, correct? And if I want to do subtraction, I'll simply say z is equals to x minus y, and I will say subtraction is this, then, or I'll say subtraction, okay, fine. And then I can do multiplication. So multiply this. Let's take a bigger value here, let's say 20. And this will be multiplication. And then we'll say z is equals to x divided by y. And this time we'll say division is, okay, I'll say div only, shortcut. Fine. This is a simple program. To do all these things, you declare two integers, value x is equals to 20, y is equals to 5. You declared another one z because you want to store some results. So x plus y you want to store in z, then you want to print it. Then you want to do x minus y, that again you want to store in z. So z will be overwritten, right? So at line number 12, z will become 25. Repeating it, at line number 12, z will become 25 because you are doing x plus y, x is 20, y is 5, z will become 25. At line number 13, you are printing it. That's fine, z is still 25. But at line number 15, you are saying x minus y, which will be 20 minus 5, 15. So z will be allocated. Will have value 15 now. Earlier it was 25, now it is 15. So it's fine. You can overwrite any value. Okay. So if I run this program, it's a pretty simple program of doing these mathematical operations, and this is printing me this. Fine. Anybody has any doubt in this program, any particular line, let me know quickly. Now let's assume that this is just single line mathematical thing, right? It's a very single line thing. But when you have complex softwares, right? So it will do a lot of things, not just the addition, right? Maybe the logic is to calculate the salary, or, when with having all the taxes imposed, a lot of things, or tax deduction, right? Those things. Then, if you write the program in this way, right, like doing multiple things one by one, the number of lines will get increased, and it will be difficult to track when we did what. Okay, it will be difficult to track what kind of calculations we are doing at what line number. This is a pretty simple question. What we have done here is very simple one, but generally in the real life softwares, right, in the background there are a lot of calculations, right? This is just addition and division what we are doing, but it may be some other complex calculations, complex things which you are doing. So it's better to write the functions, right? The functions means I'll show you what I'm saying. So what you should do is, instead of doing this addition and printing it here, do you think that this will look better? Forget about this, right? Forget about this. Can I do like add? I'll call a function, right? Add. That's it. In the main function, it will look very, what we say, simple, that I'll say add, subtract, whatever. You can give any name. It's not just this name. You can say multiplication and division. You just call this. So this looks good. This looks simple now. So this is like you are calling a function. Whenever you have something and then bracket and then there is a semicolon, that means it's like a calling a function. Okay. Now, instead of having this z is equals to x plus y here, I'll delete it and I'll make a function. So it's like modularizing it, keeping it somewhere else, and then calling that function. So I'll make a function here after the main. So this is main. After this, I will say public static void, and then there is a bracket. So this is the syntax of writing a function. Okay. And what is the function name? Function name is add. Done. And here you want to do z is equals to x plus y. That's fine. We'll resolve this error, whatever error is found. In the same way, this particular thing, I can delete it from here. I can delete it from here. Control X, and I'll make another function which will be public static void. What was that? Subtract bracket and this subtraction logic. Okay. Same thing is with this multiplication logic. I'll delete it from here. I'll keep it here. So you are keeping a block of code to simplify that. This thing in the similar way, we want to delete this also. Let me delete this part also. Control X. We want to make another function here, which will be public static void div bracket here, this one. This name, subtraction, addition, whatever, this name can be anything. You can give your own thing, right? And then call the same thing. Here, now, this program looks better. Why? I'll tell you why this is looking better. Just a minute. Let me format it. Then I'll tell you. Because what you are doing, you're saying that, hey, my integer x is 20, y is 5, and there is another variable. Do the addition part. It's like this. Okay. So it is showing me error as of now. So let me resolve it. You will have it here. So there will be no error. Let me do it for all the places. There is no error in this program now. So how clean it looks like, let's understand that part. You have a main function here. The execution will start from main function. The execution will always start from main function. And you're saying, hey, I want to perform 4 things: add, subtract, multiplication, and division, right? I want to do this 4 things. It's like this, right? So what will happen is, when this is function call, what you will see, this is calling a function, calling a function, and this is defining the function or implementation. Define function definition. It is, this is definition part of function. So any function will have, 2 things. One is calling, one is defining it. In some language, there is function declaration also. Probably in, I think, C++ language, you have to declare the function also. So that is not here. You just make a function, which is definition part, 13th line to 21st line, and we are calling it. So how the execution will happen? I'll show that part now. So let's put a debug point here. If I right click here and say debug as Java application, see here, we are at line number 7 as of now, right? And if I'll put debug point somewhere also, so that you will see where the control is, moving in your programs. Wait for some time. Okay, let me go back here. Yes, so I'm here. If I do step over, see here it is jumping to line number 15. It is not executing line number 8. I was at line number 7, but now it is jumping to line number 15. Why it is jumping to line number 15? Because I have called a function with the name add. So I call this function, so it is jumping here and it will do its own thing. So I'll go line by line. Now it is doing z is equals to x plus y. Now it will print this. Done. Sum is equals to 25. And we'll go back to 8th line. See here. Why it is going back to the 8th line? Because the work of function add is done. So it is coming back to the 8th line. Now, if I go to the next line, it is not going to the 9th line. It is coming to the 25th line because you have called subtraction function and so on. It will do the same thing. It will go to the multiplication. The control is jumping here. Now it will go to the division. It will do its own task. Now it's done. So it will come to the 12th line. There is nothing to execute now. So it will go to the end of the class and it will end the things. Pretty simple thing. So this is how functions are useful to modularize your program. Functions are useful to modularize your program. So the question was, why to use function? To modularize your program to simplify your program, because you can allocate a particular calculation into a particular code block and say, I want to call this. And you can call it multiple times. It's not just one time. It's reusable. So why we are using function? The reason is modularization. Pardon me for any spelling mistake as of now. Okay. And second thing, is reusable. It's reusable. Reusable means you make it once and you can call multiple times. So I can call again subtraction. As many time I want to call, as many times I can call this. So it is reducing the number of lines now, because you make a code block, which is, let's say, subtraction, and you're using it again and again. You just have to call this and it will do the same thing again and again. You don't have to write this code again. You just write it once, call it as many times. So this time, if I'll execute this, it is printing me, see, sum is 25, sub is 15, mul is this, div is 4, sub is 15, sub is 15 again. Okay. Because you called this subtraction function twice again, line number 12 and 13. This is very simple thing about functions here. But we'll see that maybe this is not the accurate way or the right way to make this program, because you're doing something repetitively. See here, integer x, y, and z is declared multiple times, right? But let's understand this x, y, z is nothing to do with this x, y, and z. I'm repeating it. The code block from line number 17 to 25, where you're doing something, is nothing to do with line number 27 onwards. Why? Every function is independent function. It doesn't know from where it is called and all, right? It is an independent function. It will do its own thing whenever you will call it. Another thing is, whatever variable you will declare here, it will be local variables. This is local variable. Local variable means the scope of this variable is from line number 18 to line number 25. Once you will reach to the line number 25, it will get vanished. It will be flushed out. Okay. So when we say flushed out, Java works on its own way of doing garbage collection and all. I don't want to go in that way, but in simple language, I'm saying that there is no existence of X, Y, and Z once you will reach to the line number 25 and outside it. This X, Y, Z in this function is the XYZ of its own function. Like subtraction will have its own new X, Y, and Z. It's like this. This XYZ is different from this. Though you may have same values, but this is their own local variables. Okay. It's like, one city, let's say this is one city, this is another city. Okay. Or two schools, let's say this is school number one, this is school number two. In both the schools, you may have similar roll numbers, correct? Or same name of different students. It may be possible. So this particular school may have John and Anita, let's say, right, as their student name somewhere. School number two can have again John and Anita. Again, are they both linked? No, they have their own students. It's like this. The same way they have their own local variables. Okay. That's it. We'll see that, but how to overcome with this thing? Like we are declaring it again and again. So there should be a way to resolve this issue.